Hi everyone. So yeah, I'm Jack. I've been working on the Go SDK for a little while. It actually was first contributed by a community member, Asmi, who I think unfortunately couldn't make it today. But what we've done is we've adopted the community Go SDK and we've upgraded it to work with Restate 1.0, which had some API changes from earlier versions. And we have generally added to the APIs and made lots of sort of usability improvements and things like that. So let me share a window. Soon everyone can see this. So I'm just going to kind of go from scratch. I'm going to keep things kind of simple. I'm going to start by just pulling in the template. So I want to show like this is roughly what a developer experience would be like if you were to be developing against the Go SDK. So to start us, we have this handy restate CLI. And one of the commands in it is restate example, which allows you to pull down like a list of examples from our examples repo. Currently, there's just one from Go, which is Hello World. So if I see to that. So this straight off the bat is the working restate program. It's this greeter example, which is a thing that we kind of always implement. We use this greeter example. It's the simplest possible service. It accepts a greeting, which is just something to say, and then it prints back out the word greeter. So if I just start up a restate server locally, yeah, I've been doing this folder, that's fine. So start that up, that's working. I can also run an example like this, but I'm actually going to use this tool air because it's going to rebuild the program as I change it, which is kind of helpful. So with any SDK, with restate services, they have to be registered against the runtime. So we can do that. And just like Francesco showed, similar experience, you can see that there's a service and accepts and receives JSON. So that should be all that's required to make our first invocation. If I just do this, okay, so we have a response. It says hello. I mean, this is a typical service, but let's think about some of the restate parameters and why it's helpful and what's exciting about it. So for starters, the classic durable execution use case is to sleep. So if I do that, Air should be reloading these files in the background, so I don't have to worry about restarting it. It will now sleep for 10 seconds. 1, 2, 3, 5. But if I can actually cancel it, you can see that my request is still pending. Restate is just going to complain like, okay, I can't run it anymore. If I start it up again, then restate will finish the invocation and the original request will finish. And what's cool about context.sleep instead of just doing time.sleep is that on like replay, on retry, time.sleep would do the sleep again from the start. So it's, it's not aware of what happened before, but context.sleep is. So this is us telling restate, like, I want to do a sleep and irrelevant of what happens to this process, this Go SDK process, this is how long I actually want to wait for. And that's why it's helpful. So we can get rid of that for the time being, but that's kind of just getting started to what's interesting about this. Cool. So the next thing that I want to show is state. This is like one of the most fundamental primitives about restate and is one of the key differences, I guess, to other types of service. But before I do that, I want to maybe show a little bit about how these handlers are registered. So right now we have what looks to be like a very gRPC style API. We can define handlers on some struct. Now, how is this actually working? In main.go, I have a restate server that I'm setting up, and I'm binding something called a restate service. And it's clearly doing some kind of Go reflection magic to make that happen. Unfortunately, unlike Python and Rust and many other languages, we don't have the like in-language metaprogramming. So we will end up doing some code generation, but for the time being, we have a reflection-based API. So that essentially, in the case of a service, will look for exported methods on that service of this format. Similar to Python, they need to have a context that has methods to interact with restate, and it has a return type. There are also like typed ways of registering handlers, but this is probably the most convenient way of doing it. So what we want to do in this case is to convert it to a virtual object, which is another kind of restate resource. And when we're using virtual objects, we need to use the object context. And what's different in this case is that it's keyed. So that means that every invocation against the greeter now needs to come with a key. And the first thing I'm going to do is I'm just going to re-register because we have changed something fundamental about the service and that needs to be re-registered. So you see here now it says virtual object. So we re-register. And the other thing I want to do is I want to kind of use that key. So we're now going to have a greeting and we're also going to have a key. We could do greeting and then the name. So if key is my name, you could do context.key, key. Now if I do now curl, put in a key here, and then it will do like this, hello Jack. Okay, so this is like another way of providing information to a handler, but it's not just another parameter because it also means that requests for that key are executed serially, which is kind of fundamental primitive. But more interestingly, we can store information against this key. So we can really store anything, but let's say that I want to store a number of times that the person has executed this handle before. And by the person, I mean for this particular key. So the context methods have various generic ways of reading and writing information, but they're not typed because generics are still not really capable of representing that. So what we use instead is we use these top-level methods, and I can provide this on context like that, and then provide a key name like counter. And this allows us to read information as if it's an integer. And under this hood, the SDK is going to deserialize this by default using JSON, but you can provide other deserialization mechanisms. So if I do count error is equal to this, the error is not equal to null, so I can write a lot and go. And I also need to check because it's possible, of course, the first time that instead, in fact, there is no key. But we don't really care about this. We're happy for count to just default to the 0 value of 0 in this case. We'll return the error. And these errors, I mean, it's the actual operation, the fundamental restate operation is not fallible. Like it can't actually fail, but the deserialization could fail. So you could try and turn it into an int and it's not an int or something. So this is really the only scenario in which it could fail. So now I have a count 0 value. We could add 1 to it. And then we'll just do context.set. Okay. And again, the only thing that can fail here is deserialization. Okay, so now we have this count. We are saving it. These two operations, they don't actually have to like block on sending any information to the runtime or sending it back. All of the state for the handler is provided once the handler is executed, and all of the state that the handler updates is usually sent back to the runtime when you return or when you do something else that requires communication with the runtime. So these things don't actually take any time at all, which is nice. So if I do this is number delete, now I provide the count, and we can start keeping track of this. This should just work. Okay. Here's the key. We have a different result. So this is a pretty helpful primitive. So if you think about these objects, maybe instead of a greeter, this could represent something within our infrastructure. It could represent a user. It could represent a machine, and it can keep track of this information. And you can also guarantee that any methods that you call on the object happen sequentially for a given key. And this is really, really helpful. So the next thing I want to talk about is basically just fundamentally, like, what is durable execution? We are trying to write down what we're doing while we're doing it. And so far, we're mostly doing stuff that just happens through restate. So this is incredibly easy. But of course, real applications have other effects. They have side effects, which interact with external systems that aren't in restate. This is unavoidably true. And all of our SDKs have a primitive for this called run. In Go, this is like fairly untyped, but unavoidably. But we can use this thing called run as, and we can return any type from the function. So this allows us to do non-deterministic things, fallible things, and save the results of those things, such that if we fail later on down the function for any reason, we will keep having that same result. We won't just re-invoke the whole thing. And for example, if we're doing like some expensive external operation, like, I don't know, reaching out to an OpenAI model or something, and we actually pay for it, where it takes time, we can save the results and we don't have to run it again. But most importantly, it's really helpful for non-deterministic things, because it's quite important that the handler runs on replay the same way that it always runs. So the classic example of a operation that we want to do inside a side effect is dice roll, or like any kind of randomness. So we can do something like dice is equal to that +1. So this will be a number from 1 to 6. And we can just return that without an error. So run functions can return errors because they can have fallible results where you just return an error and you want it to retry, and restate will keep retrying this forever, essentially. But they can also have terminal results, in which case they will actually be returned to here. If you return a terminal error, which you do like this, restate a terminal error, and you wrap the error like this, then this will actually be returned, the run block will stop, and then you can decide whether to either handle that error or you can just return it and say, like, this is a valid result. Because, of course, this is very Go attitude. Errors are valid results. Shouldn't necessarily be retried. It depends on what you want. But in this case, we're just going to take the result, which we know that this is infallible in any case, and we'll just give it to you. So your dice roll is, we'll put it here. Okay, so let's do results. We'll check. These errors could also represent serialization and deserialization issues, because the result of this function, it needs to be serialized. We need to write it down. Restate needs to keep track of it. This is critical for the whole thing to work. And obviously, if you try and deserialize a number into a string or something, that's going to fail as well. Okay, so let's see if this works. Okay, so we have some dice rolls. I want to show that these results, even if you fail afterwards, they're saved forever. So this is like once we get past this point and the runtime has acknowledged the result, we're done. So I'm just checking this question in the chat. And go over default interfaces with value equal panic and value. Yes, I think maybe we're thinking a little bit of like the Go context.context object, which indeed is embedded in here, like deep inside. And there are some similarities in the API, but I think really I would see this more as like a Redis style key value database in terms of how we kind of store information. It's not so much attaching it to the context, but it's more like attaching it to the key of the handler. Maybe that makes sense. Maybe I can come back to that in a minute if that's helpful. So I want to show here like what it means to fail. So if we want to do like some kind of fail, let's say that we don't like numbers that are less than 3. In this scenario, we will always panic. So what will this actually mean? You know, if we didn't save these dice results durably, then it's just going to panic over and over again until it's not a number less than 3, and then it's going to just return whatever number it finds. But that's not actually how it works in Restate. So instead, if we keep going until we have a number less than 3, it's going to keep panicking over and over again because this result is actually stored durably. If I instead now remove this, the original call will actually return, and it will show me what number I originally had, which is 2. So these results are kind of stored forever, or at least until the handler exits. But I also wanted to show like an example of doing a failure inside a side effect. So if we instead do the check here, we can do and we can say that we don't accept values less than 3. And what this means, because it's not a terminal error, it means that we're telling Restate, I want you to keep trying until you get a number that's more. So sometimes it's going to take a little bit longer because it requires a couple of tries. It's never going to actually return a number less than 3, which is kind of cool. And if I instead make this a terminal error, then when that was going to happen, it will actually return the error. See, so this is a valid result now. That's what we're telling the program. Okay, so what's next? So all of these are really just the benefits of Restate that happen in a single service, like in a single handler. But of course, in Restate, part of the benefit is that you can have services that talk to each other, and you can do this without worrying about HTTP request errors or other things that are transient values between your services. So in this case, I can just add another method to the same service, and we're going to call that capitalize. I'm going to use it to capitalize the name that we provide in, that we're currently using the key as the name. I want to make sure that that's always in title case. So I'm actually going to make it on the same object. I know we said before that when you call an object or a given key, all calls execute serially, but there is actually a way around this. So in Restate, you can provide an object shared context. And this is a subset of the things. It's a read-only view of a snapshot of state. So whatever the state was like when your invocation first started, this is the view that you will get. And we don't actually care about the parameter because we're just going to use the key, and then we're going to return a string. I'll do something like this, kings dot.
We have one question from Omar. Is this SDK already open source?
It's at restate dev/SDK-go. That's open source there.
Okay, I'll post a link in the chat. There we go.
Great, so we can do context.key. So this is just an example of some other helper method that you might want to call. The easiest way to call other methods is to use another one of our generic helper functions. So in this case, we know that we're going to get a string, so we need to tell it what the output's going to be. And we do context.object, and then we provide the name of the object, provide the key, which is going to be the same as our current key, provide the method, which is capitalized, don't need any options. And then we can do dot request, because it doesn't actually need any parameters. We just use this restate.void struct, which basically just says I'm providing nothing. So named error is equal to. So these errors that come from calls, they can generally only be terminal errors. So if this handler panicked or something like that, it's not going to return an error back to its caller because that's considered to be a transient error. But if it returned a terminal error, or if there was some issue deserializing the result into a string, then this is the scenario in which we might have to fail here. So instead of providing the key, I can't do the name. And because I've added a new handler, I'm going to do this restate def add and see it picks up on the new handler. You see that in terms of input, it now expects no input. And that's kind of figured out automatically using this reflection. Okay, so I can now do this greet. And if I maybe do it with the lowercase jack, you can see it capitalizes it. Oh, still doing that for me. Okay, so whenever I provide, it will now capitalize it. Basically, under the hood, restate isn't going to do both invocations concurrently, get the result. But in fact, if this took a really long time, let's say that this for some reason took like an hour, the caller could just stop executing, wait for the hour, and then it will be re-invoked. It will get back to this point. The result will be filled in. It will continue on like it never happened. So even if you're running in Lambda or some other environment where execution time matters a lot, it's possible to make extremely long duration calls through restate. This is kind of cool functionality for us. So yeah, I think these are like most of the primitives that you're going to use in your first day writing restate. There's a lot of other stuff there. Generally, we have broad feature parity with the other SDKs. So I'll just go through them really quickly, but I don't think it's worth us spending too much time on each one. There's a source of randomness that you can use safely, so you don't actually need to use side effects whenever you're doing like math rand or something like that. You can use our random source. We have the ability to create awakeables. Awakeables are sort of like promises that you share between services. So you can create an awakeable, get its ID and provide it to another service, provide it to an external service, even kind of like a webhook. And then those external services can resolve it or reject it with an error. And this is quite helpful in Go, so you can basically wait for however long you want for this result to come. And we also implemented the feature of selecting between futures. So if you have an awakeable that you're waiting on, or if you have a service call that you're waiting on, or a sleep that you're waiting on, then we need a safe way to kind of race those. And typically in Go, that would be done using a select statement and channels. But that's actually really dangerous in durable execution land because they are really non-deterministic select statements. For example, if there are two channels that both have a result, it will pick randomly. And if your application code is going to act differently each time it's executed for the same input, this is a bit of a problem. So instead, we have this select API that essentially provides the same functionality. You can provide it various restate kind of promises or promise-like objects, and it will allow you to iterate over which ones happened first and basically figure out what happened. So these are generally the interfaces that we have. Yeah, and then the other thing to mention is that obviously some people might be using Proto, they might be using other encoding mechanisms, but we do support that pretty much fully. So all of these methods, you can provide options, and there are options for using like Proto encoding, in which case the content type will require Proto, and decoding will happen through Proto, and there's various other things like that. And you can implement your own encoding and decoding. The thing we don't have yet, and the thing I would love to hear from users about in this meeting, is some kind of code generation whether that's built on top of protobuf, so gRPC style client and server generation with strong types everywhere, or something else, TBD. That's something that I would definitely like to know. I would say that that's the most significant change that's coming in the Go SDK. I don't think it'll be a breaking change, but we definitely will want to implement some kind of mechanism for defining a service definition and then deriving clients. Because as we saw, we're providing, not here, sorry. Yeah, we're providing the service name and the method name, and we have to know the result type. And this is not very lovely, although it's not that atypical in Go, but still, I think we could do better than this with some code gem. So yeah, excited to hear the community's feedback on this. And otherwise, I think that's everything I wanted to show. And if there are any questions, please let me know.